Hi there. For this video, we'll be talking about the perfect square trinomial. So to discuss this, we first recall that from a previous video, if we have x plus minus y squared, this one is equal to x squared plus minus 2xy plus y squared. This is the square of a binomial. Given this, we can actually do this the other way around. We can start from x squared plus minus 2xy plus y squared, going back to x plus minus y squared. And this is the idea of perfect square trinomial. This out here is a trinomial. And we say that it is a perfect square trinomial since this trinomial out here can be written as a perfect square. So we will utilize this idea in factoring some trinomials. So let's remove this one. And let's move this up out here. So let us have an example. Let's have x squared plus 2x plus 1. Now the first step that I suggest that you should do in these cases is to first check the first and last terms and check if they are perfect squares. Now, clearly, x squared is a perfect square since the square root of x squared will give us x. Similarly, 1 is known to be a perfect square since the square root of 1 is equal to 1. After this, since we know that the first and last terms are perfect squares, what we do next is we multiply these two. So we have x times 1 and we multiply this by 2. This will give us 2x, which is clearly the middle term. So upon checking, this polynomial satisfies the form of the perfect square trinomial. So we can conclude that this one is equal to the square root of the first term, which is x, the plus symbol, so we have plus out here, and the square root of the last term, which is 1, n squared. So we have factored out this trinomial. Let's move on to another example. If we have a squared minus 10a plus 25. Again, we first check the first and the last term. So a squared, is this one a perfect square? Yup, since the square root of a squared is equal to 8. How about for 25? Is this a perfect square? We know that the square root of 25 is equal to 5. So it is a perfect square. So upon checking the first and the last terms, it satisfies the given form. So the only thing left is to check the middle term. So multiplying these two, we've got a times 5 n times 2. This is equal to 10a, which is the same as the middle term. So we can conclude that this one out here is equal to the square root of the first term, which is a, the minus sign out here, and the square root of the last term, which is 5. And so we have factored out this perfect square trinomial. Let's have our third example. If we have 9y squared plus 12y plus 4. Checking the first and the last terms, we have, is 9y squared a perfect square? Well, observe that we can write square root of 9y squared as square root of 9 times square root of y squared. And we know that square root of 9 is simply 3, and the square root of y squared is simply y. So it is a perfect square. How about 4? We know that square root of 4 is equal to 2. And so the first and the last terms are perfect squares. We are left to check the middle term. Again, multiplying these two, we have 3y times 2 and times 2 out here. So 2 times 3y times 2 will give us 12y, which is same as the middle term out here. So we can conclude that 9y squared plus 12y plus 4 is equal to square root of the first term is 3y plus symbol, since we have it out here, square root of the last term is 2, and square that. And so that is the factored form of this trinomial. Let us have one final example. If we have 3x squared minus 12x plus 12. Again, checking the first and the last term. Observe that this one out here doesn't seem like a perfect square, since 3x squared, when we get its square root, we will have square root of 3x, which is not a perfect square. Does this mean that this trinomial is not a perfect square? Well, note that we can apply the idea from the previous video, which is the GCM, which states that we can factor out the greatest common monomial in this polynomial. Observe that each of these term has a factor of 3. Indeed, we can write this one as 3x squared minus this one, we will have 3 times 4x plus this one out here, we will have 3 times 4. So we have a factor of 3. So we can write this one as 3 times x squared minus 4x plus 4. And now from here, we can check this one out here. First, the first term, is it a perfect square? Well, we have square root of x squared is equal to x. How about for 4? As we have seen a while ago, the square root of 4 is equal to 2, which is a perfect square. So we are left in checking the middle term. So we have x times 2 and times 2 out here. So 2 times x times 2 will give us 4x. Clearly, this is the same as the middle term. So we can conclude that we can actually write this one as 3 times the square root of the first term, which is x, this symbol out here, which is minus, and the square root of the last term, which is 2. And that is the answer for this problem. And so that's it for perfect square trinomials. I hope you learned something from this video, and feel free to comment any suggestions and recommendations you have for the future videos in this channel. And so that's it, and that is all for this video.